Congratulations on achieving the Texas Master Electrician certification. This is a significant accomplishment that signifies a high level of electrical knowledge and expertise. The journey to becoming a master electrician typically involves several key steps and a deep understanding of electrical theory, the National Electrical Code, and practical application. Firstly, it's important to understand the prerequisites for taking the Master Electrician exam in Texas. These prerequisites often include a certain number of years of experience working as a licensed electrician or completion of a recognized apprenticeship program. Specific requirements can be found on the Texas Department of Licensing and Regulations website. Secondly, thorough preparation for the exam is essential. The exam covers a wide range of topics, so a comprehensive study plan is crucial. Resources such as the National Electrical Code, electrical textbooks, and study guides can be invaluable. Online resources, practice exams, and review courses can also supplement your learning. Thirdly, understanding the National Electrical Code is paramount. The NEC is the cornerstone of electrical work, and the exam heavily emphasizes its requirements. Familiarize yourself with the code structure, key definitions, and specific requirements for various electrical installations. Fourthly, you should focus on electrical theory. A solid foundation in electrical theory is necessary to understand how electrical systems work and to troubleshoot problems effectively. Key concepts include Ohm's law, Kirchhoff's laws, series and parallel circuits, alternating current and direct current principles, and power calculations. Fifthly, practical experience is vital. While studying and passing the exam are important, hands-on experience is what truly prepares you for the challenges of electrical work. Seek opportunities to work on a variety of projects, learn from experienced electricians, and develop your troubleshooting skills. Sixthly, you should be aware of safety practices. Safety is paramount in electrical work, and the Master Electrician exam will assess your knowledge of safe work practices. Always follow established safety procedures, wear appropriate personal protective equipment, and ensure that all electrical work is performed in accordance with the NEC. Seventhly, it's good to learn about blueprint reading. Master electricians often need to interpret blueprints and electrical schematics. Develop your ability to read and understand these documents so that you can effectively plan and execute electrical installations. Eighthly, you should also learn about project management. As a master electrician, you may be responsible for managing electrical projects, including budgeting, scheduling, and coordinating with other trades. Develop your project management skills to ensure that projects are completed on time and within budget. Ninthly, focus on communication skills. Effective communication is essential for master electricians as they often need to interact with clients, contractors, and other members of the team. Develop your communication skills to ensure that you can clearly explain electrical concepts and instructions. Tenthly, keep learning. The field of electrical work is constantly evolving, so it's important to stay up to date on the latest technologies, code changes, and best practices. Attend continuing education courses, read industry publications, and network with other electricians to stay informed. To elaborate further on the NEC, the National Electrical Code is a comprehensive set of standards that govern electrical installations in the United States. It is published by the National Fire Protection Association and is updated every 3 years. The NEC is designed to protect people and property from electrical hazards. It covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. Understanding the NEC is crucial for anyone working in the electrical field, as it provides the guidelines for safe and compliant electrical installations. The NEC is organized into chapters, articles, and sections. Chapters cover general topics such as wiring methods and equipment. Articles provide more specific requirements for particular types of installations. Sections provide detailed instructions for specific situations. Some key articles in the NEC include Article 90, which covers the introduction to the code, Article 100, which covers definitions, Article 210, which covers branch circuits, Article 215, which covers feeders, Article 220, which covers branch circuit feeder, and service calculations, Article 230 which covers services, Article 250 which covers grounding and bonding, Article 300 which covers wiring methods, Article 310 which covers conductors for general wiring, Article 400 which covers flexible cords and cables, Article 404 which covers switches, Article 406 which covers receptacles, cord connectors, and attachment plugs, Article 408 which covers switchboards, switchgear, and panel boards, Article 430 which covers motors, motor circuits, and controllers, Article 440 which covers air conditioning and refrigerating equipment, Article 450 which covers transformers, Article 500 through 516 which covers hazardous locations, Article 517 which covers healthcare facilities, Article 520 which covers theaters, audience areas of motion picture and television studios, and similar locations, Article 547 which covers agricultural buildings, Article 550 which covers mobile homes, manufactured homes, and mobile home parks, Article 600 which covers electric signs and outline lighting, Article 625 which covers electric vehicle charging systems, Article 680 which covers swimming pools, fountains, and similar installations, Article 690 which covers solar photovoltaic systems, Article 700 which covers emergency systems, Article 701 which covers legally required standby systems, Article 702 which covers optional standby systems, Article 705 which covers interconnected electric power production sources, and Article 725 which covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. When using the NEC, it is important to pay attention to the fine print notes, which provide additional information and clarification. It is also important to consult with a qualified electrical inspector to ensure that your installations comply with the code. In addition to the NEC, there are other codes and standards that may apply to electrical installations, such as local building codes and fire codes. It is important to be aware of these codes and standards and to ensure that your installations comply with them. As for electrical theory, understanding Ohm's law is fundamental. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. The formula for Ohm's law is volts equals amps times ohms, or volts equals I times R. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge through a circuit, measured in amps. Resistance is the opposition to the flow of current in a circuit measured in ohms. Ohm's law states that the current in a circuit is directly proportional to the voltage and inversely proportional to the resistance. This means that if you increase the voltage in a circuit, the current will also increase, assuming the resistance remains constant. Conversely, if you increase the resistance in a circuit, the current will decrease, assuming the voltage remains constant. Ohm's law can be used to calculate any of the three variables which are volts, amps, and ohms, if the other two are known. For example, if you know the voltage and resistance in a circuit, you can calculate the current by dividing the voltage by the resistance. Similarly, if you know the current and resistance in a circuit, you can calculate the voltage by multiplying the current by the resistance. Ohm's law is a fundamental concept in electrical engineering and is used extensively in circuit analysis and design. Understanding Ohm's law is essential for anyone working with electrical circuits. Also, Kirchhoff's laws are another set of fundamental laws in electrical circuit analysis. There are two Kirchhoff's laws: Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law, or KCL, states that the sum of the currents entering a node, or junction, in a circuit is equal to the sum of the currents leaving the node. This law is based on the principle of conservation of charge, which states that electric charge cannot be created or destroyed. Kirchhoff's current law can be used to analyze circuits by determining the currents flowing through different branches of the circuit. To apply Kirchhoff's current law, you first identify the nodes in the circuit. A node is a point where two or more circuit elements are connected. Then you assign a direction to each current flowing into or out of the node. By convention, currents flowing into the node are considered positive, and currents flowing out of the node are considered negative. Finally, you write an equation that expresses the sum of the currents entering the node equals the sum of the currents leaving the node. Kirchhoff's voltage law, or KVL, states that the sum of the voltage drops around any closed loop in a circuit is equal to zero. This law is based on the principle of conservation of energy, which states that energy cannot be created or destroyed. Kirchhoff's voltage law can be used to analyze circuits by determining the voltage drops across different circuit elements. To apply Kirchhoff's voltage law, you first identify the closed loops in the circuit. A closed loop is a path that starts and ends at the same point, without crossing any circuit elements more than once. Then, you assign a polarity to each voltage drop across each circuit element in the loop. By convention, voltage drops are considered positive if the current flows from the positive terminal to the negative terminal of the element, and negative if the current flows from the negative terminal to the positive terminal of the element. Finally, you write an equation that expresses the sum of the voltage drops around the loop equals zero. Kirchhoff's laws are essential tools for analyzing electrical circuits. They can be used to determine the currents and voltages in a circuit, as well as to verify that a circuit is functioning correctly. Practical application in the field is very important. Electrical work requires a combination of theoretical knowledge and practical skills. As a master electrician, you will be responsible for installing, maintaining, and repairing electrical systems in a variety of settings, such as residential, commercial, and industrial buildings. You will need to be able to read blueprints, troubleshoot electrical problems, and use a variety of tools and equipment. Some common tasks that master electricians perform include installing wiring and conduit, installing and repairing electrical fixtures, installing and maintaining electrical panels, troubleshooting electrical problems, testing electrical systems, and ensuring that electrical installations comply with the National Electrical Code. In addition to technical skills, master electricians also need to have strong communication and customer service skills. You will need to be able to communicate effectively with clients, contractors, and other members of the team. You will also need to be able to provide excellent customer service and address any concerns that clients may have. Continuous learning is essential for master electricians. The electrical field is constantly evolving, so it's important to stay up to date on the latest technologies, code changes, and best practices. You can stay informed by attending continuing education courses, reading industry publications, and networking with other electricians. Obtaining a master electrician license is a significant achievement that requires dedication, hard work, and a commitment to excellence. By mastering electrical theory, understanding the National Electrical Code, and gaining practical experience, you can build a successful career as a master electrician. Remember that the path to becoming a master electrician is a journey, not a destination. Embrace the challenges, learn from your mistakes, and never stop striving to improve your skills and knowledge. With perseverance and a passion for electrical work, you can achieve your goals and make a positive impact on the industry. Be sure to stay up to date with changes to the NEC and local regulations. Electrical codes and standards are constantly evolving to reflect new technologies and safety practices. Staying informed about these changes is essential to ensure that your work is always safe and compliant. You can stay up to date on code changes by attending continuing education courses, reading industry publications, and networking with other electricians. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. Be sure to familiarize yourself with these local requirements to ensure that your work complies with all applicable codes and standards. Understanding the NEC is crucial for anyone working in the electrical field, as it provides the guidelines for safe and compliant electrical installations. A good understanding of the code will also help you pass the Master Electrician exam.